All right, everybody. Um, Welcome back to episode 10 of Coding Until I Get an Embedded Internship. Today we're going to continue on with the preprocessor, and then we'll move on to a little bit of microcontroller stuff. Again, today's going to be a little bit of a shorter video, like 1 hour 30 minutes approximately, because unfortunately, again, today's kind of a busy day and kind of in the afternoon too. Tomorrow I'll probably do to make up for it. Tomorrow I'll do 4 hours maybe if I have time again. But today it will be a little bit of again, it will be a shorter episode. So yeah, let me. Okay, so let's get started. So last time we were talking about the preprocessor, which is pretty interesting because this is new stuff for me. I didn't really cover this in my university courses. So we talked about the concept of preprocessor. Preprocessor, of course, being just a piece of software that essentially modifies our C program before compilation. And there's multiple directives for preprocessors, with the most commonly ones being include and define. Define essentially creating what's called a macro. So basically some name that has another value, keyword, or whatever. And include just includes whatever. $3.40. Okay. Okay, so last time we were I did a little bit of more work last night because I felt like 1 hour wasn't enough, so I'll do a little bit more. Compiled code will often be larger. So yeah, I finished the parameterized macros last time. Okay, so we finished. I'm on the hashtag operator now. So what does the hashtag operator do? By the way, no breaks today, I think. I mean, it's just going to be 1 hour, 30 minutes full. Only 45 minute per section. So what is a token? Sorry. What the fuck? The hashtag operator can paste. a single token. Wow. So just to recap, a token, what is a token? I really wish I could control F this document, but I can't because this seems to be just a picture of the whole textbook, not like a PDF or whatever, not like a text PDF. Also, sorry for the background noise. What is a token? Macros are generic. It's not really telling me what's going on here. Okay. Recall. So this is like recall. This is from the stuff from the replacement list. So this is like replacement list elements. Some cool. Okay. Also, sorry for the excessive breathing. It's just my microphone picks up even like the smallest sounds. I don't know why. Next, the preprocessor joins I and 1 to make a single token I1. The following declaration uses mk underscore id to create 3 identifiers. mkid1, mkid2, mkid3. Oh. Oh, okay, I see. All right. So This is make ID. That's cool. That's good. Wow, okay. Okay, so let's try to do this. Let's try to do this actually. I want to see this working. Processor.c. Void return 0. That's pretty cool. Because I've never seen something like this ever. Like, just I've never seen macros like actually used like this. Do this, return x, y, question mark, x, y. I've never seen this before. What the heck? Fuck. Oh, forgot the linking. What the? Okay, wait, let me do something simple first. So that's a very basic program, right? Now let's define something a little bit more complicated. What the heck? Maybe this is enough? I don't think. Oh, wait, what? Oh, it's just the way the formatter works. It'll just format everything to be in one line. So you just need one backslash. I just realized the backslash. You don't need two backslashes to align because the backslashes implies you're going to the next line. Okay, so yeah, let's try this then. I don't know if this will work, but so this will create like a. Oh, I see. So let's do something like, I don't know, like float, right? Am I missing something here? Type. Okay. Wait, what? What the fuck? How does this compile? But there's an error here. This makes no sense. Damn, I don't know how this. Why is there a thing you're missing a semicolon, but somehow it's compiling perfectly? Or like, let's do generic max. Let's do I4 equals 1. Let's do 100. is an int max. Okay. Let's do I4, I5. How do you get that? That works. 100, right? If you get 100, that means you can also do what other types can you even can you do like okay, wait, can you even do like string? Can you do like string? Oh wait, no, char star, sorry. Like can you do like something like this? So let's do like, I don't know, char star high equals, okay, sure, high 6 equals ABC, and char star high 7 equals ABCD. Let's just do E. Wait, I don't know. Wait, that's so weird. Like, what happens if you can't return a string? Yeah, that is, I don't think that work. Yeah, that's kind of weird. What happens if you put a pointer inside here? What happens if you put like, I don't know. Actually, wait. I mean, if you put the pointer inside there, it will probably just look at the address or something like that. So like if you have like, but I don't know how you can. Like this, does this even work? Like, I don't think this works. I highly doubt. But yeah, but I think I see the general idea. Okay. Go to you water. Okay. General properties of macros. Sorry. Okay. Yeah, and I think we covered this last time. So you have to redefine. To redefine, you just need to undefine and then define again. So parameterized macros. Always put parenthesis. Whatever the fuck. Okay, that's good. Now let's go create predefined. Wow, okay. This is there's a lot to read here. C has several predefined macros. Each macro. I probably have to reread this one more time later because this is a little bit confusing. Creating longer macro. Like, actually, let me work on this like right now. So let's define echo s. Okay, so you basically just a function. It's just the macro which takes in an input and outputs the input. I think we probably. I don't understand the point of this. Compilation, not about the compiler itself. Wow. So I didn't even know this was a thing. Predefined macros. There are predefined macros. Bro, but that doesn't work. Oh, wait. No. It does work. That makes sense. Sorry. Okay, never mind. I was confused. That was just me being a little bit stupid. Oh, that's really smart. It already does it for you. What? What the fuck? Oh, what am I missing here? This is obvious. Actually, we don't even need this. Right? See them. Oh wait, I forget something. Oh, wait. Do you need this? No. So wait, I'm a little bit confused here. Is n. Okay. Oh my god. Oh, I'm so silly. I'm very silly. That's. I think, yeah, I think that's how it works. This is. No. This now it makes sense. Wait, never mind. Oh, okay, yeah. I was gonna do this. Yeah. Okay, yeah. I was so confused. I was like, what's the problem here? But like, yeah. But really, we could just, or we could have just written like, I don't know, like 5. Shit. We could have put in any number we want, and then this would work. Yeah. Remember, preprocessor directives just change the code itself, right? So you have to think about like what is actually being replaced here. So there you go. I think what predefined macros. Yeah, this I'll probably read on my own. This is a lot of stuff, extra stuff we could, but I don't think it's worth it right now. But then again, it's I think I'm gonna stop in like 7 minutes. The C stuff. Let me quickly read over 14.4, and then tomorrow we'll read over the back stuff. Conditional compilation. Oh, and one more thing I wanted to. The conditional compilation. Let us proceed with the conditional compilation. So suppose we're in the process of debugging a program. We like a program to print the variables. First define a macro, give it a non-zero value. Value of I. Damn, that is really interesting. I thought like, well, actually, never mind. It makes sense. This goes back to also like worm the cxtern stuff we covered a while back. Also, I think I might go for another 30 minutes longer. I think I have time for that. So we could push it to 2 hours, which is pretty decent actually. Why is conditional compilation like necessary? Oh well, I can see. When the preprocessor encounters the if directive, it evaluates the expression. Oh, okay, okay. Actually, this answers my question. So I was like, wait. Ah, yeah, okay. Makes sense. Yeah, just get rid of the if and end if by the end of it. Okay. Okay, this leads us to a good question, which is that like ESP32 externcy. What the heck? Okay, right here. So recall from a while back, we had this little function for our temperature sensor, our ESP32. So if it's like, so if defined, so if C++ is defined, we have to do externcy name mangling, right? And if defined C++, oh, if C++ is defined, right? So, oh, okay. So this makes a lot more sense. That's why we use this. That's why we use this macro. So we're just saying like, okay, if C++ is defined, or the first version of C++ is defined, then we need to prevent name mangling of variables. And since we're going to go through a C++ compiler, and we don't want that to happen, we want to prevent name mangling. All right, so that's good. Okay, I'm going to go to the washroom quickly, and we're going to move on to microcontroller stuff. Actually, wait. Okay, so the final thing to cover is miscellaneous directives. Miscellaneous directives. The error line pragma. Okay. So what's next after this preprocessor stuff? So tomorrow I want to finish up the C directives or whatever. I want to finish up the C directives. The rest of the stuff I forgot, I didn't read. So C99 stuff. And then we finish up 14.5. And then we move on to chapter 5, which is writing large programs. And then it's structs, okay. All right. All right, I just realized my VS Code wasn't showing, so it probably looked weird while I was like talking into the void or something like that. Um, yeah, it's because I was looking at VS Code. But anyway, yeah, I guess I will get rid of this. So yeah, just to show you. Okay, anyway, so we were doing this stuff like this. Yeah, let's move on to the ESP32 stuff. Also, let's set this. I'm gonna set this to a 53-minute timer, just in case right now. 30 seconds. Kind of shoot off, but it should be okay. Yeah. Okay, we're good. So let's move on to some microcontroller stuff. The MCU. All right. So we are going to. So last time for microcontroller stuff, we didn't do microcontroller stuff yesterday, but we did connect to Wi-Fi the last time. So the next thing I want to do is hopefully I want to start with a project, but I don't know if there's still some stuff worth learning more about. I think PWM and deep sleep are worth learning. Oh yeah, we should probably also learn what happens under the hood for Wi-Fi. So let me do. That's a good idea actually right now. Should I pick the wrong folder? That's. shit. There you go. Okay, there you go. So you begin the okay. Oh shit. Oh, so you basically from what I understand, a client in networking and communication. So client in Wi-Fi. So any device that communicates with the into Wi-Fi with the router, right? So you have the Wi-Fi, right? You got the router. Which connects to clients. What is HTTP? So what? Uh, so what is? Okay, so it does an HTTP request, and I'm assuming like you don't need to. You don't need this stuff if you already have your own web page. I don't think you need that stuff. How does HTTP request work?
Hi, I'm Rob. I'm a developer and I'm here to teach you about HTTP requests. You've worked with HTTP all the time when accessing a site, loading its content, and interacting with its content. In this video, you'll learn about the different processes that take place to make these actions on the internet work smoothly. HTTP stands for Hypertext Transfer Protocol and is used to structure requests and responses over the internet. The transfer of resources happens using TCP, Transmission Control Protocol. In viewing web pages, TCP manages the channels between your browser and the server, in this case, codecademy.com. TCP is used to manage many types of internet connections in which one computer or device wants to send something to another. HTTP is the command language that the devices on both sides of the connection must follow in order to communicate. When you type an address such as codecademy.com into your browser, you are commanding it to open a TCP channel to the server that responds to that URL. In this situation, your browser, which is making the request, is called the client. The URL you are requesting is the address that belongs to the server. Once the TCP connection is established, the client sends an HTTP GET request to the server to retrieve the web page it should display. After the server has sent the response, it closes the TCP connection. GET requests are one kind of HTTP method a client can call. They retrieve an existing resource from a server. POST requests create new resources. PUT requests edit an existing resource. Finally, delete requests delete an existing resource. Let's explore an example of how GET requests, the most common type of request, are used to help your browser, the client, access resources that it is responding to HTML, meaning it's HTTP protocol. Since your HTTP is your credit.
Okay, I think this could be useful.
Hello everybody, this is Michael. In this video, we will talk about the HTTP protocol. So why we need to talk about the HTTP protocol? Because we will set up the web server, HTTP server on our ESP32 devices. And we will use our browser on the computer to get the data from the devices and control the devices. So by this way, we no need to design special software on the computer. We also can use different devices like the mobile phone, iPad, and computer through the browser to control our ESP32 devices. So it's very interesting and very important. In order to understand the HTTP server code, we must understand the HTTP protocol first, okay?
How am I already underwater?
I'm in the same boat.
I'm in an actual boat, because I've been using Grammarly's AI for years to keep me high and dry. Try it. Grammarly can point out what's missing, right?
You know,
So this is why we discuss a little bit about the HTTP protocol here first. And the HTTP protocol is based on the client and server mode. The client will send the HTTP request data to the server, and the server will return the HTTP response data to the client. So the HTTP protocol is about the request and response data format, okay? So for the request, for the HTTP request, it has four part. It has four-part data. The first one is the request line. The second one is the head. The third one is a brink line. The last one is the body of the message. The message body is optional. Okay. So this is a request part. Compare the request part. The response part. It also have four parts of it. The first one is the status line. The second one is the head. The third one is a blank line. The last one is body line. The message body sometimes it will include all the page HTML information, the data, HTML web page data. Okay.
Duty cycle. Beauty. Okay.
So next, let's take a look at the detailed data HTTP request. Okay, for the first request line, it can so we can in the make sure this HTTP compare. So let's take a look at the request. Okay.
So since the clients, our computer will send an HTTP request to the server. And then, yeah, okay, so this is in the form of a string, right? Client.read. If the byte is a new line character. Okay. Starting to see what's happening here. Cool. So it prints the information. Oh. So there's a request from our computer, which is from the web HTTP request. And then the HTTP response will be to print off the contents in the web page. Okay. Oh, okay. And then so let's assume that okay, we wrote out the whole thing, right? This is like when we write out the whole thing, and then so this will be right there. So once we write the whole web page, then it'll check to see the client request. So if I press the button on the web page, it'll send another HTTP request with get H. And that's okay. This is HTTP. This is HTML. If you didn't, a href. So this is the link. Yeah. Hypertext reference. That's what it means. So this is gonna be /h. /h. So basically, we're saying if it will link to /h /l. If it does, then we digital write. Okay. So router is just the middleman. Router and modem. Yeah, so this is yeah, okay, good. So I'm pretty intrigued by comparator. There's a comparator right there. This is pretty cool. I'm not going to lie. But I'm getting kind of sidetracked here, so I kind of, but Broadband. Okay. So, what's next? So now I kind of understand this works. Okay, so I'm gonna save this stuff. What is... Actually, wait. I should probably think of a smarter way to put all my stuff. Okay, so we're done with that. Okay, so next. Let's try to use the PWM signal. PWM. Wow, it thinks I'm a bot. Maybe because I'm typing too fast. Yeah, let's do PWM. But first, let me recap PWM. So PWM has duty cycles and shit like that. I probably review that. It's been a while since I took an electronics. I think I took electronics in the first semester, but that's been such a long time, and it was pretty. Yeah, it was a pretty interesting course. Okay, so let's. I mean, like, you know what? I think like it's. So let me. Okay, good. Okay, let's go pin T2. I'm just gonna. These are LED. Okay, let's connect this to ground. Okay, it's rail. Yeah, so you have so PW. So for those who don't know, okay, so pulse width modulated signal is just it's just like a square wave where the essentially the percent. Yeah, I gotta review this. For the percent of the when it's on, it's dependent on the duty cycle. So if you have like a pulse width modulated signal with a 50% duty cycle, it's on 50% of the time and it's off 50% of the time. The 70% duty cycle, that means you're on 70% of the time and you're off, and vice versa. So we have to set the duty cycle to something, but I wonder how it's done here. Nah, analog right. What the heck? It's fucking turning off. So let's just do T1 instead. Is this connected well? What the heck? But for some reason T16. What? Why is this on? 16. Oh shit! Sorry. This is really pin 0, but pin 0 is like it's not working. Not sure why. Build it one more time. I don't know. Oh, I'm so silly. What the fuck? No wonder it's not working. It should be. Let's do. No, we don't need. We don't even need this. Let me just delete this. Just delete this. I don't need this. Why is it doing this? Let's do T1. T1. The duty cycle in this case would be like the duty cycle, which is 50%. Okay. Okay, it's working. What is the duty? In this case, the duty cycle would be like. The duties. Oh, okay. Where is the duty cycle? Okay. So, okay. So what if we want, like, let's say we want these. So let's do like 127. What the heck? Pulse width modulation. Okay. Okay, let me do this. Okay. So, okay, let me just read up on this a little bit more. I'm still kind of confused what's happening. An audio generation. Two states: a logical high, logical low. The duty cycle is a fundamental parameter in the context of PWM. It describes the ratio of the time during which PWM. Width. Wait a minute. So what if we do this? Analog rate. Oh, okay. Oh shit. Okay, okay. The LED is looking very nice. Like, I didn't expect that to work, but I guess it did work. Okay. Okay, now fixed duty cycle. Okay, hold on. Okay. Okay. Whoa. Oh my god. Okay. I think I kind of understand what's happening here. Well, I might need to do more research on my own for this stuff. PWM signal. PWM is kind of weird. But all right. So with that, I'm going to end the video. So today we finished up most of the preprocessor stuff for our C learning, and then today we kind of understood how HTTP requests work, and then I'm trying to figure out PWM signal. Next time I want to cover, after that, I want to cover like what's one? I want to cover the deep sleep stuff, right? The deep sleep stuff. Once we get that out of the way, we can start our first project, I think. Yeah. Then we can begin with our first project. So if we look at the calendar, so oh, yeah, it does appear again. So if you look at the calendar, so we have, okay, so if by March 15th, May 15th, that'll be our second week, right? If we finish everything, so PWM deep sleep by then we can start a project on May the 15th, and we have like a couple weeks to get that started. I want to learn so we could learn a little bit how web servers works. And yeah, so let me write that down. Okay. So there you go. I'm going to, yeah. All right, guys. So thank you guys for listening and watching. I will see you guys tomorrow. Peace out.